Okay. So, Randir, have you started the recording? All right. Great. Great. All right. And Randir, whatever questions you have related to the today's session, you should ask in questions because that gets saved in question answers, as well as I'll don't have to keep a track of two windows. One is question answer window and other is chat window. All right. So great, great. Let's get started. All right. Hi, everybody. Let me start the session now. So we were just trying to keep the two recordings. So I've made Randhir the a co-organizer so that he can also record and I've already started the recording. Great, great. So this is to avoid the fiasco that has happened yesterday and day before. All right. So where were we? We were discussing something about the. All right. All right, so I think we were discussing this page or all right. All right. So let's say we were here. Okay. So I'm already logged in through SSH. If you want, you can log in through the VETI and let me start Hive. Okay. So it's taking a bit of time. All right. So last time what we discussed was we have Hive, which can convert the SQL query into not SQL query, Hive QL query into MapReduce. The way Pig converted Pig Latin into MapReduce. In the similar way, Hive converts HiveQL into MapReduce. Just that HiveQL is to very similar to the existing SQLs. It has also tried to make the data types and all the syntax accommodating for all existing SQL, be it Postgres, MySQL, and Oracle. So it has tried to absorb their functions and try to implement those. Even the data types you saw, the data types were from all different kind of databases. All right, all right. Arjang, we can take it up after in towards the end of it. No worries. All right. So yeah, just remind me towards the end of it. So Arjang's question is this one. All right. This is a quite a popular problem. We will or do you want to discuss now before starting hype? Yeah. All right. All right. No worries. So, Arjang wants to discuss it now. Let's discuss it now. All right. So let me also pull out the session which has this particular problem. All right. I know that I'm breaking the flow, but let's go with it. Although it doesn't take much time to solve this. All right, here is the problem. So, based on the content from very large text archive, formulate the next word recommendation. For each word, prepare top five recommendation of the words that would go next. Okay. So, has anybody attempted it so far? Yeah. Not yet. So all we are trying. So everybody understands the problem, right? We are given. So our overall objective is to provide the next five words recommendation when the user types a word. What should the user type next? Okay, and we should be able to guess that based on the frequency of the words. Okay, if you're given a large text archive, if we crawl, then we will know from that corpus of the data that there is that what do people speak next after a particular word or phrase. It's this problem in general is called n tuples. Okay. And it's a quite well known problem. All right, so basically here what exactly are we trying to do? If we are trying to give the suggestion the way your mobile keyboard gives you the suggestions. Now, to get it done effectively, we need to have the humongous data so that we know what do people speak generally after a particular word. So all we need to do is we need to use, either we could basically count by ourselves that after this word, the for each word we keep a big array in which word and what follows the next. If we do that, or we can use MapReduce. Let's see how we can use MapReduce. All right. Easier way to do is use this kind of a mapper where we break it down into two words. So after how R comes, after R U comes, and after you, nothing has come. So after Ram, happy comes, and happy after happy, birthday comes, and so on. Okay, and after two, U comes, and after U, happy comes. Like that, we have created key value pairs. Now, when Hadoop groups it, it will bring all the values together, all the values together, and and that will solve our problem, right? So there are minor problems with this approach. One is that one is that computation of frequency, my these words that follow r might be millions, right? The words that follow 2 might be millions, right? If the text contains billions of words, therefore the reducer will be overloaded. Therefore, the reducer will be overloaded. All right. Now, in order to solve this problem effectively, you might have to form another kind of. So generally this is good enough solution in which while mapper will convert it into key value like this, the reducer will compute the top n words. Okay, top n most frequent word after how. Okay, so it's like two-phase map reduce for each of the word. All right, to Further solve this problem, what you can do is you can form the key as how, followed by how dash r is one of the key, and value is say how. So so when you okay, so this will basically this will be, let's say, 1. So we'll have the frequency of each tuple, uh, and then at the later point of time we can, once we group all of these values together, and then we order it, then we will have clarity on which tuples generally go together. Once we have that number, once one, so out of that, if we pick up the most frequent one, then we shall be able to quickly give the suggestions. All right. So so there are two approaches we talked about. One is, so one could have been like in memory approach, in which we keep a big hash table where key and values are there. Or we could do it using MapReduce, where key is how and value is r. And then inside the reducer, we compute the top five most frequent word, and then we have the word and the recommendations. Okay. The other approach is to avoid the overhead on the reducer. We could bring out, instead of counting, we basically count how good friends are these two words, okay, by counting their frequency. If they are coming together, therefore, if they are rarely coming together, they have only come once or twice, we just remove them. Okay. So that will decrease our overhead, and then we can do in the second pass, we can do the rest of the computation. All right. So Arjang, did you get the picture? No. It's called n tuples. Or let me call it, there is an array. This is, called n tuples, not an array. This is called n tuples. All right. Yeah, this is called n tuples. All right. Let me also figure it out. Okay. As far as I remember, it's called, the official name for n tuples. This is called n tuples problem. All right. So yeah. All right. here is what Randhir has to say. All right. Okay. Okay. So I thought about the approach where you combine two words and one, but how do you display five frequently used? Right, right. So basically, in the approach which I'm telling, it's kind of optimization. It's kind of optimization where I'm removing after doing this kind of triple, I remove the non-frequent words completely, and then do the rest. Right. So it's basically kind of optimization where we are assuming that all those words which are not repeated quite frequently after a word can be removed. Okay. So it's just one phase of optimization which improves the the problem solving to a very large extent. Although it's not very accurate. All right. So that was about word and next word suggestion. Okay, so moving ahead. All right, back to Hive. Any questions before we start with our Hive discussion? Okay. Sridhar, did you try to attempt this problem? This one? Sridhar's question is did not understand the n tuple. So yeah, I'm asking. Okay. All right. I think a better thing for me to do is I'll pass on the solution and then we will discuss. Okay. So solution is basically need to be put into diagrams. The second one, only then I'll be able to make sense out of it. So here it's like a two phase map reduce. In first phase we'll just compute key value pairs, and then and and then after that for each of the word we will further do the map reduce. Once we have removed all the words whose frequency is less, we will we will again break it down into key value pairs like in the this examples. Okay. So first we will remove the non-trivial one, I mean non-frequent ones, and then we will form this kind of a key value pair and run it again. Okay. All right. Okay. So yeah, going back to the going back to the hive. All right. So yesterday our hive was not working because the memory it was demanding our we had reconfigured our server as in resource manager inside using Ambari. Using Ambari, we set its maximum memory to little lesser, which was around 1 GB, and Hive was asking for more than 1 GB, so it was denying it. Therefore, we could not connect at that point of time, and I could not connect to the admin panel that time. All right. Now let's try to say do Okay, so it's not connected. Yes, Bina. All right. Um, is it still breaking the voice? All right. Looks like only one person can connect to Hive at a time, and that is something which we did not realize. Just now, before starting the session, I realized that only one person is able to connect to Hive at one time. All right. Ouch. 5665 H2 cloudxlab.com. So I think the way out would be to now, I think now is the right time to create your individual accounts rather than sharing the account. Okay, so we'll do that. So yeah, inside your this account, you will also see your personal login. Ouch. So both the places we have Hive. So I'm going to kill all Hive. PS3. I'm really sorry, but I'll have to kill somebody's Hive. Okay. PST gives the uh, process tree, and also gives you the user ID and other details. So looks like it is stuck, and all right. So I've tried to kill it again. Let's see what happens. There's something else that is a problem. I think we'll have to revisit our cluster config. Maybe we have limited the total number of connections which can happen parallelly. All right. All right. Should we do one thing then? Since because Hive is more about practical, and I want to do the live practical for you instead of talking theoretical. So why don't we start with NoSQL? What do you say? Because looks like there is something wrong. I had tested it before we started the session, and again it's not connecting. Let me try to do that. Let me try to test it over the week. All right, rather than wasting everybody's time. All right, no worries. All right, Randhir. Okay, okay. So yeah. So Randhir, the result you are seeing is actually the grep result, which means there is no process running. Only it's showing the. Okay. So the question from Sridhar is that what about the classes on Thanksgiving weekend, which will be 11/27? All right. I think I'll have to have the session because we have already extended too much that the session is going to overlap with the rest. But anyway, let me send an email to everybody and checking if they want they are having a break on that. All right, let me just put that in my to do. All right, so here we have to put the Hive also. Hive test. All right, let's start with NoSQL. Probably that's far more interesting. And uh, also, for all of you, in very simple words, if you really want to give it a try, uh, the Hive. I will try to explain in couple of words. So all you need to do is create a table, cre- uh, create a table like managed table, like this way we have demonstrated, and then you load the data into this table, and after you have loaded the data you can start querying. It's actually very straightforward. All right, so for those who are a little impatient with Hive, they can basically start right away by creating a table like this and then loading data into this table using the step shown in the next one, and then start querying querying these tables. All right. All right. So regarding Thanksgiving, I will let you know um, after discussing with the team. All right. Okay. So we have session number five, four, six. All right. All right. So let's start with our discussion on NoSQL and HBase. All right. So if you have no clue about SQL, you can say that you are an expert in NoSQL in your CV, and that's all right. So let's start with our discussion. So before starting with the discussion on NoSQL, let me refresh the definition of scaling out and scaling up. Vertical scaling versus horizontal scaling. So vertical scaling or scaling up is when you want to increase your computing power. Instead of using a normal computer, you start using a computer with bigger configuration. That's called scaling up or vertical scaling. Like in this diagram, we are showing that there is a person who has one horse cart. He want to carry more stuff. So he upgraded it to an elephant cart. While scaling out or horizontal scaling means instead of having one horse to pull the cart, he's using multiple horses in the cart. Okay, he's using multiple horses in the cart. You can see that. Now that's about horizontal scaling or scaling out. So I hope it is clear. All right. So what is the point we are talking here? Earlier, the belief before 19 and before 2000, the belief was to go for vertical scaling, like choosing an elephant instead of a horse in case of dire situations. In case of situations which demand more heavy load. Okay, now here is the story which probably almost every company had gone through who has scaled up, or every internet company has gone through. Every popular internet company probably has gone through this phase, or they have already shut down. So earlier what used to happen is that, let's say, you few people got together, built this brilliant product, and then you launched it, Launching meant was you moved the code from your local workstation to a remotely hosted shared server and let the magic begin, right? And you really built a great product which everybody wanted. Okay, so service became popular. Too many reads started hitting the database, and and you had already thought about this situation when your database will start getting hits. You will do is you will put memcached. So in the initial public launch, you just told your family and friends that, hey, I'm launching this school service. They told their friends and families, and they the service became popular, and you quickly realize that the data, if you start caching the data instead of every call going till the database, let memcached give the data, and whenever that data changes, you refresh the memcached. Now the moment you bring a cache in play, what exactly happens? There's always a delay between the record getting updated and this cache server getting refreshed. Okay, cache is basically in memory solution where you keep the data in the memory pre-prepared so that you don't have to hit the database. Now if you keep something pre-prepared, that means it will take some time to refresh it. Till that time it will be serving the old stale data, right? Therefore your service is no longer strongly consistent, right? Consistent always meant that whatever you have written to the database, and when you read from the database, you will get the latest value. But the moment you bring the cache, because the moment you bring the cache, the consistency is no longer there because it takes time to refresh the cache. Correct? Now, second is you added cache, it was working pretty perfectly fine. Service continues to grow in popularity, and suddenly there are too many writes hitting the database. If there are too many writes hitting the database, then what happens is that you start scaling your MySQL or your database up, because at the end of day, your web server, though it takes the load, but it transmits all its load to the database or the backend services, right? So you vertically beefed up the MySQL database with, I mean, you, instead of having single core, you started having 16 core, and you have this 128 GB RAM, and you bought really fast hard drives, or maybe solid state hard drives, right? Now story became, now you're pretty happy for some time, and then at this point of time you must have done this because you got some funding, some seed fund or some angel investing or maybe some VC money, with which you bought this hardware, and at the same time you started adding more and more features. You started adding more and more features. You hired a couple of product managers whose duty is to figure out what will work, what will not, and they started adding more and more features to the page, to your website. Now as you add more features, there'll be more joins. Let's imagine that what is it that Flipkart or Amazon has to do to present the page. There'll be a table containing ratings, there'll be a table containing reviews, there'll be a table containing the identifiers and the basic page, because not everything could be put into a single table. There will be multiple tables wherever there is a one to n relationship. Okay, so as more and more features accumulate, there will be more and more joins that would happen to serve the web page, and that's where the complexity start. So you start denormalizing your data to reduce joins. What does it mean by denormalization? Instead of having multiple tables to join, you start having a single table. You start having a single table such that you do not have to keep joining the data. Okay? Or sometimes you pre-prepare a lot of XML and JSON and keep it ready. Now, the moment you talk about denormalization, the people who are from DBA school will go furious at you because that's not what we were taught as DBAs. We are taught to keep normalized the data. Okay. Now, no matter what, the next thing that starts happening is after denormalizing this data, if your server keeps growing in popularity, you did couple of PR and it really brought a lot of traffic to you, things are still too slow. Things are still too slow, and so you stop doing any server side computation. So you stop doing any server side computation, which means there are no stored procedures, there are no triggers, and you stop doing all the server side computation. Instead, you start pushing that to the client side. Now, still, after doing all of this magic, there will be some queries that are still too slow. You will keep on periodically pre-materialize, as in pre-prepare, that we know that these are the things which user will demand. Therefore, let's just pre-prepare everything instead of preparing at the time of user asking for those. Okay, so you try to stop joining in most cases. But at this point, you will find that reads are going okay, but writes are getting slower and slower. Okay, so when writes are slower and slower, it's because of the indexes, and therefore you remove the indexes. Now, if you notice what happened in this time, okay, so you remove the indexes, you remove the triggers, you remove the stored procedures, you no longer want consistency, you no longer want primary secondary kind of relationship, foreign key and primary key relationships because you denormalized already. So do you see what's happening? You undid the database. You undid the database. You want the database only for storing the data. Okay, and this is the typical story of every company or every internet company which has got the load. Okay, so in the situation where you foresee such kind of thing happening with your service, you go for NoSQL. You don't want the database you with all these features. You want the database just for putting the data, taking out the data. And that's where the NoSQL comes in. So Amazon learned from its mistakes. They started with Oracle and they ended up with Dynamo because of the Christmas time. They could not cater to the users. They were shut down at once. And that's when they realized that they cannot use the database because of these reasons. Database cannot cater to that many requests. All right. So till now, whatever we discussed in our sessions, first problem which we tried to solve was our usual file systems were not solving our problem. Second, one single computer was not good enough for computation. Third, now what we are discussing is our database is not good enough to handle big data. All right, therefore the NoSQL comes into play. All right, so why NoSQL? First, to handle and store humongous data. Second, to provide high availability, meaning to provide the to so that we can cater to many concurrent users. Third, scale out architecture. What does it mean? Scale out architecture? It means that we have lots and lots of users coming in. Okay, so that if we have lots and lots of load coming in, we can add more and more machines without having to worry about installing, deleting, moving the data. Okay, so right now, like we have H1, H2, H3, it won't be too difficult for us to add one more H4 if more users come to us. Okay, so we'll be adding more and more servers to our cluster. This is called scale out. So no such NoSQL databases also provide the the scale out architecture. Today you are catering to 1,000 users, and tomorrow you can cater to easily 10,000 users. Okay, just by adding few machines, and so on. You can keep on adding machines, and it will rebalance automatically. That's called scale out architecture. And since it's a scale out architecture, then generally these systems are designed such that you can use the not so high end servers. Not so high end servers means commodity hardware, so that you don't need to buy really expensive machines. Okay, so these are the reasons why we talk about NoSQL. So see, this question is, what about update operations if using NoSQL? And I think you're carrying the impression that Hive was NoSQL server. No, Hive was just a query analyzer, query to to MapReduce converter. Okay, it doesn't provide you the update, but every NoSQL is designed to provide you the CRUD operation really well. CRUD means CRUD, create, retrieve, update, and delete. Okay, so all of these NoSQLs are really great at providing you the CRUD operations. So what is NoSQL database? It's basically a database that has distributed architecture. Now, since there is a distributed architecture, which means there will be multiple servers, and these multiple servers will share your table, right? And when you share a table across multiple servers, so I'm talking really generic here. So the meaning of a table could be different in case of different databases. Like in case of MongoDB NoSQL, MongoDB, which is a NoSQL, the table means collection. Okay, collection has a document. Similarly, in case of HBase, we have table. Cassandra, it's called what do you call? Uh, s- uh, it's it's called a column family. So you will see all these definitions, but the idea of a table in which you put the objects will always be there in almost every NoSQL. So imagine this: you have hundreds of servers. That's what is the meaning of distributed architecture. You have hundreds of servers catering to the users. Now, all these 100 servers might be sharing a single big table. Some of the rows on one machine, some of the rows in another, some of the rows on some other. That's actually the typical case in almost everyone. Now, if each row is not identifiable, uniquely identifiable, then you won't be able to cater to your users, right? Because it will be difficult to locate where is that particular row which user is asking for. Correct? Therefore, every record has to be identifiable. In case of HDFS, in case of our HDFS, which is also a distributed system, every file was uniquely identifiable using the file path. In the similar spirit, each row in these systems is having a uniquely identifiable ID. Okay, the full form of NoSQL is not only SQL, and it's no non-relational, open source, horizontally scalable, schema free. So I'll explain to each one. So not only SQL is just the expansion given in the retrospect. It was just a Twitter handle from which the NoSQL evolved. And non-relational, as in they don't have the primary key foreign key relationship. Again, if you go back to the case study which we discussed quickly, you will realize that foreign key primary key relationship is something which you do not want in the production machines. Okay. So therefore, almost every NoSQL tries to stay away from relational structures because they make it monolith. Monolith means carved out of single stone, which cannot be divided. So if you try to keep makes a system relational, what happens is you cannot distribute it across multiple machines, and therefore most of the NoSQL databases are non-relational. Then open source. If a database is not open source, nobody adopts it. Okay. So to have a good adoption, people keep it open source. So horizontally scalable means that horizontally scalable we have already discussed this part. So scale out architecture, meaning you have one big table here shared with three machines. If fourth server comes in, this table will further split and move to this fourth one, and now there will be four parts, meaning it is automatically rebalancing itself. That is horizontally scalable. And schema free meaning it has no schema, as in there is no schema in the table. All right, because schemas make the structure rigid, and that causes the sloppiness. Easy replication, as in the copying the replicating the data is easy. All of them have simple APIs. When we say simple API, most of them don't provide you the SQL. They provide you a get put kind of interface. Okay, they manage huge data. Yeah, and okay, and you have commodity servers. So Randir's question is, so one NoSQL database is for one project or product? Not really. Every NoSQL database provide you namespaces, provide you the tables, okay, and and you can keep the data in those tables. All right. So there are basically four kinds of NoSQL stores, starting with column oriented, which are they look more like our traditional database. Like for example, HBase, Cassandra, Accumulo, they have tables, and tables have columns, and they have rows. Okay, so Cassandra and HBase are classic example of column oriented and wide column. We'll come back to the definition of column oriented. You will find it a little strange, but most of the new definitions are generally like that. So the second type of the database is document oriented, such as MongoDB, Couchbase, and ClusterPoint and MarkLogic. Now, so the document oriented databases are those in which you a table is basically collection of documents. A row is kind of a document, kind of a JSON document. You imagine when you think when somebody says to you a MongoDB, this is a table in MongoDB. It's basically a collection of rows in which there is only one column. All right, and this column contains big JSON object. Right, so that's what is the MongoDB, in which MongoDB gives you a big collection in which you can keep on adding or deleting or updating a document. A document is something which has key value pairs inside it, and you can search based on these attributes of this document. So those are document oriented databases. You can see here that when storing into MongoDB, we can easily store such kind of thing. Let's say in MongoDB there is a table or collection called TV shows. A TV shows collection contains TV show. Each document is a TV show, and this TV show is a complex structure containing. Each TV show has many seasons, and seasons have many episodes, and each episode has many reviews and has many cast members. Okay, so this kind of complex structure can be formed in JSON kind of uh, structure and put into the database, and that basically makes up the MongoDB. Now, while looking for episodes, you can query based on these attributes, saying where where document dot episode dot reviews contain a particular keyword. So those kind of searches MongoDB provides you. All right? Yeah. So Veena is saying she's not able to hear intermittently. So Shridhar's question is, if it is NoSQL, what about dimensions and fact? All right. When we say NoSQL, it does not mean it doesn't have dimensions and it doesn't have facts. Every document, for example, in MongoDB or in HBase, you have these attributes, these columns, as you will see further. Okay. Now, this third kind of database is called key value pair. Key value pairs are the most simplistic and most primitive form of databases, and they started with Dynamo. Most of NoSQL games started with Dynamo. Even Amazon has now moved from Dynamo to a bigger HBase kind of database. The Dynamo has grown into a column oriented one from a key value. So those most simplistic one which are used in most of the systems are key value kind of databases. Say for example Memcached, Redis, Voldemort, and Dynamo. And fourth kind of NoSQL stores are Graph. Also, please note that it will be unfair to call these systems as databases because they are more like stores. Uh, For for somebody to be called as database, it needs to provide a lot of functionality, which none of these actually provide. Okay, none of these. I mean, except for the advanced ones like Cassandra and MongoDB, most of these do not provide a query language. So Sridhar is saying ID for each row, which is same as RDBMS. In case of RDBMS, it's not mandatory, but here it's mandatory. All right. Now coming back to the discussion, the fourth kind of database which is come recently is graph kind of database. Those are great for storing the complex relationships between the object. Okay, complex relationship between the object. So here, yeah. So basically, when you have to store the data in the form of graphs, probably graph database is more useful. All right. Any questions at this point of time? All right. So yes, Arjang, the HBase is column oriented. We will go into the details. Now, this is a quick summary of. Now, Randir's question is, what happens if you alter the table? Okay, so you are allowed to alter the table, and actually, you would not need to alter the table because in most of these NoSQLs, since they don't adhere to a schema, which means each row can have different column sets. Okay, as we go forward in case of HBase also, each row can have different column sets. Okay, and if there is a new row, it can introduce new columns, and it's completely schema free. All right, now coming back to the SQL databases and NoSQL databases comparison, it's a standard one. You can take a look. You must have done a comparison by now. While on one hand, all the SQL follow the CORDS paper, which went from for relational databases, while NoSQLs have different types. The development history of SQL databases is they started in 1970s, while NoSQLs started very late. Now, in the examples, the SQL databases are MySQL, Postgres, Oracle, while NoSQLs we have already discussed, MongoDB, HBase, Cassandra, Neo4j. Data store model in case of all SQLs is relational, while here it's different based on the type. Schemas, SQL database have data types are fixed, structured data types are fixed in advance, while in case of NoSQL, it's dynamic. To scale the SQL database, in case you demand more users, more data, or more number of requests to be catered, you have to scale it vertically, meaning adding more hardware. NoSQLs, uh, NoSQLs scale horizontally. The development model in case of SQL databases is mix, but in case of NoSQLs, it's open source. All of the SQL databases provide ACID transaction. ACID means atomic, consistent, and durable and isolated kind of transactions. So those are the four properties of the transactions, ACID. And NoSQL databases, you have to okay, so in certain circumstances at certain level, they provide the transactions to you. For example, in case of HBase, you can there is a row. Each row can be updated in a single transaction. Okay, similar is the situation with MongoDB. Each collection can be updated in a transaction, but it varies from one database to another. Data manipulation in case of SQL is SQL, while in case of NoSQL, there are different APIs. So SQL databases are generally configured for strong consistency, but you can relax that by making it by allowing the dirty reads. Okay, NoSQL databases depend on the product. Vina's question is, does splitting happen here too? Yes. So splitting of what? Yes, splitting of a table happens here too. That's correct. The way we had big file, we cut it into portions and sent it. In most of these, whether Cassandra, MongoDB, CouchDB, or HBase, they internally slice the table and put it in multiple machines. Okay? Yeah, you guessed it right. All right, so here is a very important aspect of NoSQLs. So probably everybody in the beginning when NoSQLs were being invented, people were working on it. So people were trying to get really high performance and high number of users and scalability and also ability to do the distribution using MySQLs. Everybody was trying to use the NoSQL database, the SQL databases so as to provide the great availability in terms of lots of users should be able to access it. Lots of we can divide the data onto multiple machines as well as the consistency. We were trying to do all the three and nobody was successful. Okay, nobody was successful at that point of time. Somebody named Eric Brewster came up with this theorem called cap theorem. It says that no matter what kind of system we are talking about, n- nobody can provide all the three C, A, P. Somebody has to compromise somewhere. Somebody has to compromise somewhere. So consistency means all the nodes see the same data at the same time. There is not a slightest variation in the data. Second, the availability. Everybody sees the same data at the same time. Okay? Sorry. Availability means a guarantee that every request receives a response, meaning when we say available, available means you connected to our server and you got a response. Okay, whether failed or successful, that's another thing, but the server should not keep crashing or your request should not keep on getting timeout. Okay, so which means the server is available to respond to your request. Third is partition tolerance, meaning in case your network got partitioned, as in your net, some of the servers got out of the network, you should still be able to happily serve your customers. Okay, because some of the machines keep on getting shut down, if your system can tolerate that, that means your system is partition tolerant. All right, so I hope the three cap is clear to everybody. Now I will go into the details why the three things are not possible at all. All right, now if you look at these diagrams, I thought about it. It took me some time to come up with these diagrams. I thought about all kind of configuration we have as of today. Most of the systems can be thought of these three kind of architectures or some derivation or a combination of these three. Okay, now let's look at the first diagram. The first diagram is our traditional relational database. And what is happening here? There is a single machine. Everybody, whether they want to write or read, they are talking to this single machine. All right, so this kind of system is not really partition tolerant, because if this machine goes down, your users will not be able to access anything. Partition tolerance means if some of the nodes, some of the system failure happen, still your system continues to cater to your users. Here, neither it's partition tolerant nor it's completely available. If there is one user who has engaged the server, or there are, say your server's limit is total 100 connections parallelly concurrently, so your availability in this case will be 100 users. Okay, so it's not very greatly available. Consistent, it's consistent definitely, because if a user writes something and some other user comes in just a moment afterwards, just a nanosecond after this user has written, they will see this current data, they will not see the old data. All right, now the second diagram, you see the second diagram where there are two machines A and B. The all the users who want to write the data, they go to A, data flows over the wire to B, and all the readers who want to read from the system, they can read from B as well as from A. Now, in this case, what you see here is those users who are reading from B, they will be reading the stale data unless the new data arrives over the wire. Now, when the writes happen on A and those changes are transferred over the network and reach B and then apply on the table. Till that point of time, during this transit period, all the users who are reading from B, if they're reading the same table, same record, they'll be reading the older data. Therefore, it's not consistent. It's not consistent. People are seeing the older data. Now, but this system, this A to B kind of system is available, in the sense more available than the previous system. Here users are the reader is it's available with respect to readers. Okay, it is available because users can either read from A or read from B. They're reading from both the places A and B, and therefore it's fairly available to all. Partition tolerant, as in case A goes down or B goes down, the business doesn't stop. Therefore, it is partition tolerant. If both go down, only then the business will get stopped. But in this case, you can decrease the probability of failure by having more servers like B who can serve as reader. So Veena is saying, so the second system is better overall. Kind of yes. If you are okay with slightly consistent or eventually consistent means eventually everything is going to be okay, because it's not when the replication is happening, the data is getting transmitted from A to B, there are no chances that conflicts will happen, and the system will end up in a contradictory state, right? Inconsistent state. It's not an inconsistent state, it's kind of transit in the data is in the transit, and eventually the things are going to be okay. If you can tolerate this kind of situation, then the system would work for you. Yes. So Caesar's question is, even RDBMS we will have backup. Yes, and that's what the third diagram is about. So the way we kept an RDBMS, we generally kept A and B two machines, A serving to all the users. Okay, while we keep a dormant replication, a server which is kind of a standby, which we are keeping as a backup of A. The data at B is generally slightly older, okay, and is always catching up, while A, who is serving to readers and writers, okay, while A, who is serving to readers and writers, is under the heavy load. Here, all the readers and writers are coming to A, while B is just dormant, a sleeping system which is keeping the backup. All right, which is keeping the backup. All right. So Veena's question is, MongoDB and Zookeeper came after HBase? Not really. MongoDB and Zookeeper, yeah, Zookeeper came after HBase. There was something called Chubby service. In a paper from Google, when Google published those papers on HBase, they has described something called Chubby service. The Chubby service is what became Zookeeper. Somebody followed that architecture and created Zookeeper. MongoDB kind of was came in parallel. All right. So you can see the third diagram. Now the third diagram is consistent but not available because it's under the load all the time. Is also partition tolerant in the sense that in case B fails or A fails, we have somebody keeping the data backup. All right. So it's not greatly available. If you see, remember the our HBase name node. HBase name node avoids the actual read and write. Okay, by handing over the read and write to the individual databases. All right. So this is what the diagram about, and you can see that. So we can see, you can say RDBMS with backup. All right. So you can see clearly that the moment we try to provide a system where partition tolerance and availability both are there, it becomes little inconsistent, and that's what is the whole uh, NoSQL about. So most of the NoSQL actually settle down to this kind of a model, the central model, in which they are okay with eventually consistent, but they are not okay for not giving the availability and partition tolerant. All right. Now, the other definition which we want to discuss right now is something called column oriented databases. What does it mean by column oriented databases? So, if you have a table like this, it has two columns, emp id and name. Okay, emp id and name. This is employee id and the employee name. It has got 10 Zoe, 12 Mary, 11 Kathy. Now, under the hood, how do you store this data? If you are using a CSV kind of a format, you will be storing 10 comma Joe, then new line, then 12 comma Mary, then new line, 11 comma Kathy, then new line. And that's what is row oriented way of storing the data. That's a good row oriented way of storing the data. Okay, so we are saying first row 10 Joe, second row 12 Mary, third row 11 Kathy. That's row oriented way of storing the data. Sometimes what lots of people who manage humongous data, they realized if we store one column together, if we store one column together, then the compactness of the data will be really, really high because the compression is great if you compress all these records together. Because here, generally, one column stores similar data in that column. Therefore, it's generally easy to compress the data. Imagine, imagine a column called age, right? Imagine a column called age. That age is only 100. The age can vary from only 1 to 100. Therefore, if you represent age by a byte array with 3 bytes or or say 6 bytes, okay, that should be good enough. Sorry, 6 bits, okay. So in the 6 bits, you will be able to represent the age of anybody. Instead of dedicating 8 bytes, you can store it in 6 bits. Therefore, having, or you can think of, let's say, names of all the people in India. Okay. Now, if you have only the names of all the people in India and you try to compress it, you can always give a very small symbol to very common names, and therefore you can compact it easily. Therefore, more similar is the data, more is the compaction, and therefore, when you have column oriented way of storing, as in storing all the values from a column, therefore, all the data which is similar in nature goes together. It's very easy to compact it by compression. Okay, so therefore people started storing in these new databases like HBase and Cassandra. People started storing the data in column oriented fashion, right? you can see that. So we are storing 10, 10, 12, 11, and first, and then Joe, Mary, Kathy. That's what it's about. So 10, 12, 11, Joe, Mary, Kathy is what we are storing. All right. So Veena is asking, do we have a primary key concept? Yes. It's mandatory to have a primary key in HBase. We will talk about it later. But right now, what I'm trying to explain is the column-oriented database are more compact and more easy when it comes to the data. Okay, so you can see that as the data grows up, the laws or the rules which we lived by changes. All right, now databases like HBase, they are more politically correct in the sense that they created something called column family oriented databases, meaning columns who are part of the column family, they always stay together. Okay, so each column family is stored first. So inside each column family, the data is stored row wise. So let's say that this is a table which has two column family, CF1 and CF2. So we are talking about the storage here. We are not talking about the general representation of the data. At the outset, to the end user, it will look like a normal table which has rows and columns. So here and column family. So here the column family oriented database means all the data in a column family stays together, okay, and is stored together. So all the data in this column family will get stored together. What does it actually mean? It means it means that it will be stored like 10 Joe, 10 Joe, 12 Mary, 11 Kathy, and then the second column family will be stored. Okay, first this column family and then this column family. Now that's what you see: 10 Joe, 12 Mary, 11 Kathy, and this big number you see, 3-digit number, is basically the row ID. All right, and then you have 12, 33, 45. All right, makes sense to you? Ravi's question is, how about we have more columns with repeated data that can also be stored? Okay. Sridhar's question is like storing composite key columns together. Yes, kind of. Okay. So Ravi, could you explain more? I want to understand your question a little more. All right. I'm hoping that you are able to understand what do I mean by column family oriented database. Data in columns is stored nearby. Data in column families stored together. So Ravi's question is, what if Mary's age is 20? So it won't make much of a difference. It will be 20, 23, 23, and 45. Now Randeep's question is, how do you decide what are column families? Okay, so yes, any data you want to be stored together, you would put in the same column family. Yes. So we will discuss it. That's part of the diagram. That's a part of the diagram. That's a part of the design. When we talk about data model, we'll talk about these aspects. Okay. Now coming back to Here the column family. So Veena, give me a second. I'll explain what's the benefit of column family. Now imagine this. Imagine this. If you want to convert a table into true column oriented database, you create one column family per column, right? You'll have CF1, CF2, CF3. CF1 for MEMPID, CF2 is for name, and CF3 is for age. Now, this table will become the column oriented table, right? Now, if you want to make it a normal row oriented database, what you have to do is just keep one column family for the whole table, right? Now this column family concept gives you enormous amount of control over how you want your data to be. Some of you might argue that, hey, row oriented way is better than the column oriented. Some of you might say, no, 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 column oriented is better. Column family orientedness gives you the complete control. How do you want to keep your data stored? Okay, so all the data that you think should always go together, you know that when user is coming to ask for certain data, and user is always going to ask for first name and second name, then you keep first name and second name in the same column family. That will ensure that same the data in the same column family is stored together. All right, so yes. Now, Ravi's question is then what is the then how does it what do I mean by when I said that the compression and all of this? So still, if you have column family here, okay, if you have column family like this, when you try to compress this data, it's the compression algorithms would generally work better. it's 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 found lately in 2011 probably that if you have similar data and you are trying to compress the similar data, you will find a great compression, you will find a good compression. Okay, you can think of it that in case there is a song which has many repeated line, you can actually cut it short by creating a symbol for each line and putting that symbol, creating a shorthand and replacing the full line with that shorthand. Similarly, if the more data is similar, you can always internally, I mean, if you look at any of the compression algorithms, how do these compression algorithms work? They figure out the commonly occurring strings which can be shorthanded, and they shorthand those kind of commonly occurring uh, arrays or commonly occurring numbers, and then that compresses the data a lot. Good, good. So here Vina's question is, so while reading, so can it just scan a column family instead of the whole table? Yes, that's exactly the purpose of having the column family in HBase. Okay, so all right, so these were the concept, starting with the cap theorem, starting with what is NoSQL and the column family oriented databases, scaling out and the general vertical scaling, and why we need NoSQL. So now probably we are ready to jump in with HBase. All right. So let's start HBase after the break. Let me increase the font. All right. So can we start now? All right. Great. So let's talk about HBase. So HBase is a column for family-oriented database or data store, and it is consistent and out of CAP, it is C and P. It's consistent and partition tolerant. Okay, why we don't call it available, highly available? Because all the writes and read requests go from the same machine. Okay, the initial request goes to the same machine. We will talk about it when we go into the detail. It's based on Google's paper on big table. Okay, it's based on the Google's paper on big table, and it's good for hundreds of millions or billions of rows. Okay, it's it's great for handling humongous data. If you have hundreds of millions or billions rows, it's great. If you are just focusing on maybe 100,000 rows, then it's not good for you. For 100,000, your MySQL is good enough. Okay. Now, all right. Now, it's strongly consistent. Okay. And with respect to read write, not eventually. Okay, so it's kind of a third kind of architecture. We'll talk about it. And there are something called automatic sharding. Sharding means dividing a table into parts or dividing any data into parts and distributing over the cluster. So it has automatic sharding, and after sharding, it puts the data into region servers. Okay, so there are something called region servers and there's something called master. Master receives reads and writes, and it hands over the data to region servers. All right. Now there is an automatic region server failover. In case one region server fails, the other one takes over. All right. Now here you can see that. So in case one region server fails, other can fail over because other one has the copy of it. We will go into more details. Now, it has a good Hadoop and HDFS integration, meaning when you want to run MapReduce over HBase, you can run HBase on top of it. You can run MapReduce on top of HBase, as well as HBase stores its data in HDFS. Okay, HBase stores its data in a certain format inside HDFS. It's massively parallelized processing. Okay, it's massively parallelized processing in the form of MapReduce. It provides you MapReduce but does not provide you a good SQL query. For SQL querying, you will have to rely on third-party systems. It provides you an API via Thrift and in Java. There are ideas, there are internally, it provides something called coprocessors. If you are an H-based developer, you can create coprocessors which will run on various servers in the background. Okay, so just like triggers. So similar to the database triggers, you have coprocessors, and it has something called Bloom filters. Bloom filters are a way to make the search faster. All right. So coming back to the architecture. So in case of HBase, you have a master and there are many region servers. there are many such servers like this region server. Master is only for keeping the index and keeping track of the index, while region servers are the real workhorse. The data is stored inside region servers, and master and region servers communicate to each other via a service called Zookeeper, so that in case one server goes down, master does not have to keep track of it. Instead, Zookeeper keeps track of which region server is up and which region server is down. All right. So Zookeeper is a general service which is used in that form. Also, this HDFS, the HBase uses HDFS exclusively for storing the data. So each region server stores the data in H file, and that H file is stored in HDFS. Okay, so Veena is saying, is Zookeeper like name node? No, Zookeeper is like a third party service which provides a way of failover to anybody. Okay, here HBase master is like a name node. It is the index of it's this is the one who keeps tracking the what is where. All right, just that instead of directly communicating with each other, instead of directly communicating with each other, these systems, they communicate via Zookeeper. For that matter, in case of HDFS, the name node and backup name node, they communicate via Zookeeper. If you remember our design in where we wanted to have the automatic failover in case of HDFS, the recent features, those also communicate via Zookeeper. Randir's question is, can pig or hive be used on on HBase? Yes, that's right. Pig or hive both can be used on top of HBase. All right, now let's look at the diagram a little bit more. So the users go to master. Okay, master keeps track of what are the region servers by the way of Zookeeper. Zookeeper, you can think of like a big whiteboard on which master keeps on reading from that whiteboard, and region servers keep on going to that whiteboard and writing their name on it. Okay, and that name keeps on fading, and if they don't go there and write their name again, their name will get faded. Okay, so that's how you can think of it. All these region server, they keep on going to the Zookeeper cluster and write their name that, hey, I'm up, my IP address is this, and that name keeps on fading every few seconds, so they have to go and write again. In case it fades and they don't write again, that means they are considered dead, and therefore master will get to know that this machine is dead. All right, so these region servers, all of them, including master, everybody keeps their data in HDFS. That is something interesting about the architecture, that the whole system lives on top of HDFS. All right, now every table that we store in HBase is automatically partitioned into horizontal regions. Okay, horizontal regions. So you can think of data as if, let's say, okay, if you have big table, this is your big table. Okay, you have written some data in it. This is some data you have written in it. Okay, now this was your nice table. The moment you put it in HBase, and HBase will split it into regions. This is one region, this is another region. It has cut it into two regions. Okay, so these are regions. So you can change the color to maybe green. All right, so tables are automatically partitioned horizontally into regions. This is region number A1 and region number 2. Every region has got a big number which gets generated internally. And each reason comprises a subset of table rows. A reason is denoted by which table it belongs to, okay? And the first row which is inclusive and the last row which is exclusive. Meaning if we are saying that our reason server is reason our reason is what do you call reason is say table 2, okay, and and say 1 and say 10, okay. That means it will have 1 2 up to 9, not 10. That's what it means by last row exclusive. If somebody is saying that, oh, this reason is this big, that means these are the rows. Initially the table comprises of a single reason, okay. So Randir is saying, what is the purpose of reason when the data is saved in HDFS with a replication factor of 3? You will get to know that. Okay. So since the rows have to be displaced, so the whole table is not stored in a single partition. Whole table is not stored together. First, it is sliced into these regions, and then each of these regions, okay. Uh, so when you initially store the data, okay, so initially you will have a single table, single reason in a single table. And as and when the data grows beyond certain size, you can define the size at which the reasons should split. So initially there will be one reason, and as and when more and more data keeps coming, and the moment we reach the upper limit of the reason, what happens is this data is split into two. The table is split into two regions, and in case so now this will split into two. Then again, both of these, how can I cut it? Can I cut it in any way? So imagine this. Can I cut it in any way? All right. Now imagine that we have, all right. How can I? Never mind. So each of these regions will become the two parts, and again, both of these will individually, let's say, they keep on growing. Both of these regions keep on growing. More data is coming here, and more data is coming into this region. And after certain time, both of these regions will further split if they cross a certain threshold. All right. And generally, the layout is this. The HBase master will have this detail saying this table has got these many row IDs, and every row is denoted by row key. Every row has a key. Vina's question is there a relation between reason and a column family? So each reason contains part of the column family. All right. All right. Coming back to what we had discussed here. So let's say that your rows are from A to Z. So the keys, so it will look like this. If you have three region servers, region one, server 1, server 2, server 3. There are six reasons starting with A. A is inclusive while C is not included in this, which means A and B and B and so on, but not C. And And here C to F is in the third server, and C to F is in third server, and F to I here, and I to M here, and M to T here, and T to Z here. Okay, so this is how the data is distributed across machines. Okay, so one machine could contain multiple regions. One region server could contain multiple regions, and there could be multiple regions there. Okay, so these region servers could be nodes where you don't have HDF name, I mean node manager, name node, or data node, or maybe a resource manager. Okay, these nodes could be those where there is no data node, or or the name node, or resource manager, task tracker, anything, no services there on the machine. Region servers are nothing but processes just like data node and others. Okay, so here you can see clearly that the regions are that the big table has been sliced into small regions and has been distributed. Now as and when the insert will happen, all these regions will grow in size. And again, in case the one who grows any region which grows to the pre-configured value will be split further into regions. So it's basically it's basically like a big binary tree, or you can a big tree in which the data is expanding and they are spreading across. It's like growing structure. Okay, that's how they're able to manage the humongous data. All right, now that was about region servers. So before going further, I would like to discuss the model, and probably data model will govern how do you behave, how do you behave, uh, how do you create your own data, own servers. Okay, so probably the best definition of HBase is given by the person who created Google's big table. And as per the paper, the big table is sparse, distributed, persistent, and multidimensional sorted map. These these six keywords actually define the whole database. There is not a single word which I can take out, not a single word I need to add additionally to define the database. Okay, so you can think about HBase also in the same manner. HBase's data model is it's a big map. And when I say map, I don't mean Google Map. I mean hash table, or a map in terms of the data structure. Okay, so so when you think about HBase, you think about it like a big map. And what is a map? Map is a key value pairs. It's a collection of key value pairs, which means the map, it has to have, every record has to have a key and there is a value. Okay, and what is a value? Value could be multidimensional. Similarly, when I say multidimensional, it means the key could also contain more attributes. Key could be composed of multiple values. Similarly, value could be composed of multiple values. Value could be a complex object. It is persistent. Persistent means anything you write into this map is not lost if the machine is turned off. Distributed, meaning this map is distributed across the cluster. Okay, and next property is sparse. Sparse is something very important. The dimension, multi-dimension we talked about, those dimension could vary from one row to another. Okay, so this table, although we are calling this HBase table, each row can have different set of columns. Each row could have different set of columns. One row could have many columns while other row could have very few columns, and that is the important part. All right. So yes, HBase is stored in HDFS internally. You will get clear picture. I'll explain to you. I'll show you actually where it's storing. That will give you a very clear picture. All right. So the HBase is organized. The whole database data in HBase is organized into tables. There are many tables in in, in HBase. Now inside the table there are further rows and column family and columns. We'll go into the details. And table names must be the strings with which you can create a folder in the file system. Okay, because these table for each table it's going to create a folder in HDFS. All right. So tables contain rows. Within a table, data is organized, stored in according to its row. Every row has to have a column. Sorry, every row has to have a row key, right? The way when you think about a table, you always the when you studied the SQL, always a column is identifiable by a name. Similarly, a row is also identified by a row key, right? So therefore, all right. So row keys do not have a data type and are treated as byte array. Okay. So row keys do not necessarily have any data type. The way and the internally HBase stores the data which is sorted by the row key. Rows are ordered by row key, just like primary key enforces the data organization in case of normal databases. Also, since row keys can be any binary data, you could stuff a full movie file into row key. Does that sound strange? You can put a full music MP3 into the row key, not only the text or the number. And as a matter of fact, I have done that in case of Cassandra. So basically, the row key sometimes acts like a storage. Now inside the row key you have column family. Uh, Sorry, inside every row you have column family. Data within a row is grouped by the column family. The column family impacts the arrangement of the data. They must be defined upfront. So when we talk about HBase table, you don't need to while creating an HBase table, you don't need to create you need don't need to define the columns or their data types upfront, but you just need to tell what are the column families it is going to have. Okay, so column families are defined upfront, and while adding data you always say that for this row key and this column, inside this column family please add this data. Okay, we will show you that. All right, so column family must be defined upfront and are not easily modifiable. Every row in a table has the same column family. It's not necessary that every row need to stuff the data into the column family. And column family name like table name are are should be file system safe. Meaning that for each column family, the system is going to create a file in which all the rows of the region, and all the columns inside this column family are going to be stored in that file. Okay, so let's try to log in. All right, now so we talked about table contains rows, and column family column family is basically a group of columns which we need to define upfront, and every row has same column families, although may not have the data to put in every column family. Now comes the column. Data within column family is addressed by a column qualifier. Column qualifiers need not to be specified in advance. Column qualifier need not to be consistent between the rows. Not every row need to have the same set of columns. Some rows can have first column, some row can have second column, and some row can introduce all of the new columns. They may not adhere to the existing columns. Therefore, the data in this HBase table is sparse. That's why we call it sparse. All right. Those who are coming from the relational database background, for them it will be a little awkward, but you'll get used to it. Also, like row key, column qualifiers do not have a data type. Therefore, you can put any data inside the column name. Does that sound strange? You can put any binary data inside the column name. And a cell is basically the actual place where HBase stores the data. Okay, the cell is the intersection of table name. For this table name, for this row key, for this column family, for this column qualifier, for this particular version, we store the value of the cell. And what is the version? Every cell has got multiple versions, and values in cell are of the type byte. It's a byte array, meaning it's a binary data which you can put it. Every cell are versioned. The value of the cell are versioned. Okay, meaning there are multiple versions of each cell. When we put new value to a cell, either we can say that, hey, I'm trying to put new data for this cell. Okay, either we could say that we are trying to put new data for the cell, all right, or we could say that for this particular version this is the value. Okay, when we are not specifying any version ID. It takes the current timestamp as the version number, and the version can be defined per column family. How many versions should HBase retain for each cell is defined per column family. By default, the number of versions is 3. All right. Vina's question is, we define the number of column families but do not specify number of column in each column family. That's correct. We also do not tell, we define that, hey, this table is going to have A, B and C column families. Okay. Now while we adding values, we say that for this row key, for this column, in this column family, we are stuffing this particular cell with this value. Okay. Yeah, that understanding is correct, Veena. All right, now going ahead. So, in a table like this, you can imagine the various definition which we have just talked about. These are the row keys. Okay, 1, 2, 3, 4, 5, 6. These are the row key for each row. This is the column family of name and residence number. This is another column family called office. This is called personal. And for each value, there are timestamp 1 and timestamp 2. And these things are cells. All of these are cells. How many cells are there? 6 into 4, 24 cells are there. Uh, don't include this row key as a cell. Yeah. All right. Now, the other way of looking at the same data is at the top is row key. If you think, if you are from the mindset from the hierarchical way, first comes row key, then comes the column family, then comes the column, then comes the timestamp, and then comes the actual value of the cell. Timestamp or the version is the same thing, just that timestamp is the default value for the version. All right, now let's discuss a use case. Let's discuss a use case of does it will I be able to log in into. All right, I'll have to log in into admin panel and let me first check what's the status. All right, so while we define, I think we should first, before jumping into it, let's try to create a table. So you can see that we started the HBase cell by saying HBase cell and then say status. That gave us the status of the servers. Then we can create a table like this. We are saying create my table in my column family. So it has been able to create the table called my table. Now you notice that we are defining a column family upfront. All right, happy? Now, when we say list, we get the list of all the tables here, T1, ramp, and my table. Okay. Now, if you want to see what is there in my table, we can simply say my table, or we have to put a single quote around it. You can see that it has given row and column plus cell. There's nothing inside it right now. Sometimes you don't know if you want to see eh, portions of the database, I mean, a list using regular expression, you can specify that. So we are saying dot star, as in this is the regular expression saying anything uh, before table. Now, let's say you want to insert something into this table. We are saying put my table row and this. Okay, so into the my table, we are inserting this row with these values. So please pay attention to this. This is my table. This is the row key. This is the column definition. You see, column definition says first column name, column family name, colon the column name. Okay, so we are saying for this table, in this row, for this column family, in this column, we are putting this value. Okay. So we have again put it. So it is basically updated accordingly. Okay. Now, if you want to see what's there inside the whole table, we can simply say things like this. Okay. So you can see there is a row called row 2 and the column called this, timestamp is this, value is this. Okay. If you want to put a newer value, we can put quickly and have this. Okay. Now the timestamp had changed. Timestamp is the one which is defining our value. Okay. So we can have a look at more commands. Okay. We can have a look at more commands and get the values in this manner. All right. There are many more commands. I just want to keep it very simple for now. Now let's say I'm trying to get the value for row 2, not row 1, row 2, and for column family here. You see that? All right. So describe my table, and you'll see all the things in detail. It shows you the detail about the table, as in how many minimum versions, how many the okay. So keep I mean all of these details are coming from the default configuration. All right. If you want to delete a table, you can delete first disable. But before disabling the table, what I would like to do is I would like to insert more table. Now, what I want to demonstrate to you is I can create another row. Let's say row one. Okay. Right now, how many what all data was there? There was only one row. Now I can add one more row called row one and insert another column and put the data in like this. Also, at the same time, I can go back to the row number previous one and insert one more column into that, column 3, and put the data. Now you can see, scan my table. So you can see that now in row 2, there are two columns, column 1 and column 3, while in row 1, there is only one column called column 2. Now, if you want to add more columns into row 1, we can simply say things like, this is my value. This can be something else. Now, this is what I want to demonstrate to you. So you see, for row 1 in the column 1, it's a text. While for row 2 in the column 1, it is the number. Now, you see that there is no schema to be followed here. There's no schema to be followed. All right. So timestamp is just a mark of the version. Okay. It's not creating one new row for each timestamp. Row 1 and row 2 is the key. That's correct, Randhir. So Randhir's question is, can we do key as auto-generated? Not really. It doesn't allow an auto-generation of the keys. And if you look at the other systems like MongoDB, which allow auto generation of the keys, are actually, you know what they're doing? They are just generating a big random number and then inserting it. Okay? They are just generating big enough, safe enough number and just generating it. If you want, you can also do the same way. HBase leaves it up to you. Just that in case you give the same row key as the previous one, which is already existing, it will update that one. Okay. So Randy's question is, how do we make sure the key is unique? That's actually a very difficult task. Okay. So general strategy is that we pick up an attribute which we know that is a critical attribute to differentiate between one record to another, and we stick to that particular attribute, right? Generally business logic will come up with some strategy the way we are going to give you an example. So it all depends on what data are you storing in this table. What is the How do you differentiate one data record from another? From there you can always deduce a key. So Ganpati's question is, will it throw error if we try to insert duplicate records? Not really. If you try to insert the same record with the same row key, it will just update the same row key. It will not insert a duplicate record. Okay? As we try to do, let's say here, you can see just now we tried to insert the same thing. Let's insert again. It's not throwing any error. Instead, it's basically updating the same table. You can see that the timestamp has been updated. Now, Randir's question is, what if we project allow to change key in future? Can that ever happen? If you try to change the key, the whole philosophy of a table crashes down. You will have to create a fresh table, read the data from this table, put into the other. Okay? You'll have to do it that way. You have to basically create a fresh table and then move the data one record at a time. Vina's question is, if a cell can store any data type, how is the compression possible, as we discussed earlier as the advantage of the column oriented DB? Okay, so the compression algorithms are clever enough to figure that out from the bytes itself. Okay, so that was a very, very abstract example which I was trying to give in order to explain that the compression under the hood actually follow those kind of strategies. Okay. So Ganpati's question is, can you retrieve just one record? So yeah, you can see that here we are saying like this, we can retrieve the value of a column. Okay. Now, if we do not provide a column name, we get all the values for a column. Okay. All right. Now you can see that what we are doing is, in case there are multiple column families, you can also retrieve the data for the whole row, for the whole row, and or for a single column family instead of multiple. Okay. All right. Is it clear to you? So what I did was I said get my table row 1, that gave me all the columns for this table. Then I said get my table row 1 and my CF, that is the column family. But unfortunately we have just one column family right now, so we don't have much data right now. In case you want to add one more column family into my table, it will be impossible at this point of time. You will have to create new table, take the data programmatically one record at a time, and insert into the other column family. So Ganpati's question is, if I know the table, how do we know the primary key? Is there something similar to describe command? So yes, I showed you the describe command. Describe my table. Okay, by default, row key is column family. Row key is the primary key. There's only one thing, one primary key, which is row key. And I mean, that's the whole premise of the game. Okay, there's the whole premise of this. Vina's question is, yes, can we update? Of course we can update. So if we want to just say, if we want to, let's say for row 1, for row 1, for column 1, we want to put something else. Okay, let's say we want to put something else. So we can simply say put and it will update it. You can see that it got updated. So with put you can update. So timestamp does not look like time value. It is time value. It's an epoch since 1970, 1st January. These are the millisecond since that time. Okay, these are the milliseconds since that time. And how do we know? How do you change? All right, there is a way to check this. Ouch. Let me just see if I can. All right, basically this is the minus date equals to this at. So when I divide 1, 2, 3, yeah, this is correct. You can see that it is done at this time. This is UTC. Okay. So yeah, that's a timestamp. Does it make sense to you, Randir? So this date command can convert seconds since epoch, and this is what it is. So Vina's question is, how is the update happening internally when you cannot update HDFS file? So it's basically destroying the block and reading again, creating again. Okay, that is how it's doing. Just creating a new file, destroying the previous one internally. All right, so that was a quick description of data model. Now, this is something important which we are going to discuss, and this will help you design a great system using HBase. It took me some time to architect the first data model in Cassandra. The same thing is true in case of HBase also. So Randir's question is, it did not give us an error if we try to insert the same key but update the data. Is there a concept of rollback? No, it doesn't have a. Instead of a rollback, it gives you the version IDs. It gives you the versions of the row. You can enable the versions. All right. Per cell, it can give you the versions. No, we'll not be covering the Cassandra here. All right. All right. So the data model which we are going to discuss is the main use case why the big table by Google was invented to keep the data of the whole World Wide Web into a table format. Okay, this data is around a petabyte, which is crawled by Google every now and then, and maintained in a system like HBase. Okay, and this was their main architecture, how they kept the data into this table. Okay, so please pay attention here. So All right. So here, so this is an example table that stores the web pages of the world. Now, what they wanted is first, they want to store the whole data of all the users. Second, all the web pages. Second, they wanted to keep a track of which web page is linking to which web page and with what name. That is the objective. First objective is to store all the web pages across the globe. Second, second, knowing that which web page is linking to which one, and while linking, how they are linking to each other. When I link to some web page, give a href as well as the text, link text and link URL. There are two things. So if I'm linking to you, I'll be linking to you with a link text. That link text is what is being displayed, and that matters to Google. If the same link is being displayed by different name, that means there is something wrong. Okay, so therefore Google wanted to keep a track of it, and probably every crawler wants to track of it. So as and when they are downloading data, they're analyzing the page, that okay, this page refers to which other pages, and then they go and crawl that also and keep a record of this, that which page is linking to which page. So the way they have structured this table is in the following way. The first column family is contents, second column family is anchor. Inside column family called contents, the default, which is blank, the column name which is blank contains the whole HTML data. In case you want to store something like PDF, MP3 or binary, you can create more columns inside this column family called contents. Now every row is identified by the URL, by the website, by the name of the URL is how they're tracking the whole website. Now this the and inside the anchor text, inside the anchor column family, they are adding more and more columns as and when they figure out that a website is pointing to other website. Let's say cnnsi.com is linking to www.cnn.com. So they will add one more column into it. Okay. So first for okay, so let me try to explain the full flow. First, they went to www.cnn.com and downloaded this HTML from there, saved it here. Now, there is no anchor tag right now. Then, after some time, they went to another website called cnnsi.com and they downloaded the data from cnnsi.com and kept the content here. While they loaded this content, they realized that, okay, this content is this website called cnnsi.com is pointing back to www.cnn.com. So they created a column inside anchor column family with the name as cnnsi.com. The name of the column is cnnsi.com. Then after some time, they noticed that cnn.com is being referred by another website called my.look.ca. Now for that also they created another cell. Okay, and they are keeping as and when they are encountering more websites who are linking to cnn.com, they are adding more and more columns to it. If there are a million websites linking to cnn.com, there will be a million column in this particular row. All right, there will be a million columns for this particular row, and that's how they're storing it. Similarly, if there is microsoft.com's website and there are 100 people linking to Microsoft back, there will be 100 columns in that row. Okay, so that's how they are keeping the data. All right, so this is something. Otherwise, in our traditional case, we will keep three tables, right? There'll be one table only for contents, then there'll be another table defining the relationship between one website and another website. Okay, so instead of that, they have merged the two and created a relation like this. All right. So looking at a single row, they can clearly tell that what is the content of this website and who all are linking back to this website. And more attribute you can keep on adding to it. All right. So now the important part is here, there was another hidden requirement here. The requirement was to keep all the website of the same domain together. Same domain should keep all the subdomains content together. Now, as we know that the table is ordered by the row key, right? If there are so all the one reason will keep the data ordered by the row key, right? I mean, all the reasons for that matter will keep the data ordered by the row key. All that's how we are able. If the data is not ordered by the row key, we will not be able to define a reason just based on beginning and beginning and the end of this. So if we are not able to having if row keys are not ordered, then we will not be able to define a reason based on the endpoints beginning and the end, right? So row keys are ordered, strictly ordered, based in the binary order. So if we want to bring all the domains together the way we are saving the data, if we want to bring all the subdomains of a domain together, what we can do is we can reverse the URL. We can reverse, instead of saying www.cnn.com, www.cnn.com, they have written com.cnn.www. Okay, therefore if there is some another domain called email.cnn.com, that will come next in the next row, or maybe in the previous row. Okay, so that ensures that all the data of a website, all the data of a domain is stored together. So if you have to crawl, if you have to go through all of the data of cnn.com, you just look for a key called cnn.com, and then you start reading from that point downwards. That will give you that will give you all of the data of cnn.com's subdomains as well. Okay, now, so I hope this answers my a lot of questions. So row key is a reverse URL so that all the domains, all the subdomains of a domain come together. Content Contents column family contains the page content. Contents column family contains the page content. Here there is a column name is blank. All right. Another column family contains the text of the anchors that reference the reference the page. So CNN's homepage is being referenced by both cnnsi.com as well as mylook.ca. cnnsi.com is referring to cnn.com by this particular text. Each anchor cell has one version. The contents column has three versions. Okay, so here there is only one version. Here there are three versions. Okay, if you have one more website called xyz.co refers to cnn.com as news, then it will have one more column called anchor.xyz.co with the value as news. Vina's question is, why do we need to reverse the URL? Okay, so why? Because we want to bring all the subdomains of a domain name together. Otherwise, they will be far more spaced. All right. Do it make sense, Veena? No? All right. Now, if you think about Microsoft.com and email.microsoft.com and www.cnn.com and email.cnn.com and cnn.com. Now if you see, if these domains, if they're sorted, if we sort them, okay, so see, all right, let me just try to sort it. Why it's not sorting? So here is, so now you can see first CNN.com, email CNN, then email Microsoft, then www.cnn. That's not correct, right? That's not correct, right? But if you reverse it, if you try to reverse it, okay, if you even say and not this, anything, dot followed by dot star and dollar, then I say $2 dot $1. Even if we do this, okay, even if we do this, this is not right. So now you can see that, all right, now you can see that if we represent the data as com.cnn.com, and here also if we move it like this, com.microsoft and com here, and then we sort, you can see now cnn.com. All right, I'm sorry, let me just change this a bit. So we reversed it from most significant to least significant. Now you can see that com.cnn, all the website of com.cnn will be stored like this in the database. So scanning the data will be easier because there is no other primary key for us. All right. All right. So when you look at the column family called anchor, it has got uh, this row key, this timestamp, and this value. All right. This is how, when you say scan table, this is what will happen. All right. All right. So let me do a recap. Indexing is based on the row key. Tables are sorted based on the row key. Each region of the table has sorted row, key space, start key, and end key. Everything in HBase table is stored as byte array. Atomicity is guaranteed only at row level. There are no multi-row transactions. The transaction is only at the row level, which means you can modify the whole row in a single shot. Okay, you can add more columns, delete some value, and put something else, and so on. So you can do that, and I think there is something called delete as well. There's something called delete as well. So there is replication, snapshot, DML, not DDL, DML. Yeah, there is delete all, put. Yeah, so we can say delete. We could say delete and my table, and we could say row 1. Okay, so now you can see that the data is removed. All right, that is something which we did not talk about. All right, so we could do the deletion of the things at a row level. Column families have to be defined at the creation time. Column filters are dynamic and can be defined at right time and at any time. Column names can be added more and more as and when we want. They are stored as byte arrays, so you can put the data into them. And all the data model operations return data in this sorted order. Okay, now let me try to see where is my data. Okay, let's try to log in into this, and at the same time let's just try to get the login password. Oh, I'm already logged in, so our login is, I think, different, so we'll have to go with another login. All right, I've logged out, so we could say S. All right, and let me just copy paste. All right, so here you can see the pig library, not pig library. What we want to do, we want to go into file browser. So we want to see where is my table stored. I think this will give you a clarity. Okay, let's go up here. There is something called apps. I think it is noted here. All right. So all that, I think we have discussed all of this, so we can move on. Right here. So the data by default is stored at this location. We can go and modify this. So here under this particular location in HDFS, our table is stored. You can see my table here. Inside the table, you have reason. This is the reason ID. Okay. Inside each reason, there is a column family. Inside column family, it will store the data. If we flush, then it will get stored in the table. All right. You can see that. So under my table, it has created a folder per reason. There is a single reason right now. As the table grows, there will be more and more reason. This is how the data gets stored. Some of you were curious. That's why I'm showing it, although it's not required to know. Inside this, each region, there is column family folder. Inside column family, this is the name of this is the what do you call, this is the file that represents the column family's reason. Okay. All right. So you can go inside it, and it's a binary data, so you would not be able to make much sense, but some of the data should be partly visible to us. It's fairly blank right now. So it has a bloom filter enabled. You can see my CF column 3, row 2, and all of that information. So the data is in binary, so won't be much readable. All right. So for each reason in each column family, this is how data is getting stored. All right. So row updates are atomic. No matter how many row column it constitutes, the row level transactions are there. All right. So if you want to scan the data programmatically, you will have to create the HBase scanners like cursors in traditional database. They have to be closed after the use. Scanners return row in the orders, and user obtain scanner by the way of saying htable.getScanner. All right. So here the scan parameter contains the row key from where to start, the row key to stop, and which columns to return, and optionally a filter to run on the region server side, okay, before giving you the result. And each invocation of next on rs would make a trip to the region server again. All right, here is little ugly code, but I hope it's clear to all. Let me increase the font size. I'll go one by one. So when you programmatically access the HBase, just like just like we created a configuration before connecting to our MapReduce, similarly we first create a config. Then if you want to make a change to this config object, we can change here. Once we have config object, we are saying here we are creating a config object, and based on this config object we create something called admin object. This admin object will be responsible for doing probably everything. After that, we create a h table descriptor. You will be surprised to know that after HBase guys created this API for accessing the HBase, the same has been adopted by Google for accessing their big table. All right, because they like the API. So now at this point of time, you can create an object representing the table, and then you can create another object that represents the column, and then you can add a column family with this name. So basically column descriptor or column is, here we are creating a column family. So we are adding a column family to this table, and then using the admin handle we are saying please create this kind of a table. Okay, please create this kind of a table. Afterwards, once we are done with the creating table, we can again go back and ask admin for the list of table. We can say admin dot get me the list of tables. We'll give the list of tables, and here we are checking whether our table, this table name, is in the tables or not. Once we are done checking that our table has been created, we can put the data into this table in the following format. Okay. Okay. Okay, so here we are saying table equals to new table. This is the name of the table we are creating. And then we are saying create a binary data for row 1, create a put data for row 1, and and this is the actual data which we want to put into the row 1. So we are saying p1, as in to the put command, we are adding the name of the row and the actual data which we want to write, and the actual value which we want to write, and so on. Okay, so although this data bytes, yeah, this data bytes is being utilized here. So we are saying for row 1, for column family called data, please add these columns and then save. Okay, once we are done with putting this data into table. So this is the put command. A put command can be composed of many such operation. p1.add, p1.delete, p1.others, and then we could execute it in a single shot by saying table.put. All right, and then we can get the data using get. So this basically gives us a complete Java API to access the data. All right, now if you want to execute a MapReduce logic, you can do that in the same way we did for our normal MapReduce. Here, instead of extending the another mapper, we will basically extend table mapper and do and we will get in the map function, we will get a row. Okay, we'll get a row and the value, the result in which the row and the value. And after that, we will get a context object. Into the context object, we can put whatever we want to. All right, we can put whatever we want to. All right. Similarly, we create a my table reducer by extending the table reducer, and in the reduce, we will get the key and the list of values, whatever we are giving out here. Here we are giving out iterable, here we'll get an iterable, meaning a list of values, and then again we can write to the context exactly the same way, the way we did the map reduce. Okay, now we can stitch that in the similar fashion, just that we can provide some more configuration. We can first create a config object, and then we create a job and set jar by class, and then we can also create something called scan, so that instead of applying MapReduce on the whole table, we can apply scan on only subset of the records. Okay, so here this is where our map reduce job is being initialized. Okay, so we are saying initialize my mapper job, initialize my reducer job. Inside mapper, we are defining scan, source table, and mapper class name. These are the mapper output keys, mapper output value, and this the job object in which we are tying it together. Similarly, in the reduce job, we are defining a table, we are defining a class, and we are defining a job object. After that we are saying job dot set number of task 1. Okay, so that will basically set the number of tasks, uh, so number of reduced tasks on which we have to run this reduce. Okay, because mapper will be governed by how many reasons we have. Map task will be governed by how many reasons we have for each table. All right, now after this we'll wait for the job completion, and that's all. All right, this is how our mapper job, map reduce job is done against it. All right, now there is an idea called Bloom filter. So Bloom filter is basically a simplification of key value pair, and say Bloom filter is a very good strategy. All right, let me try to answer one question before I move forward. Question is from Veena. If we have an employee table and later we decide to add column address, how do we go about adding address for all employees? Okay, so it all depends where is this address stored. So you can add, you don't have to add. All right, so let me go back to my question. So first, it is not mandatory to add the address column to all of the employee before adding it to the column. Please note that the column is a property of row. Column is not a property of table. So you have to go through the list of all the employees, put more and more column. When the way I demonstrated to you that using a put command, I was able to add a column later on at the point at a later point of time, right? When I said put my table row number 1 and this column, you can try by yourself by creating a table, try to put any arbitrary column into that row. You'll be able to successfully do that. This HBase is completely flexible with that. All right, so you will have to go through each row, do the put on each row key. That's all. All right, was I able to answer your question, Vivina? All right, another question from Ravi. What if for same example I want to add the address under a new column family? You are free to do so. You are free to do so. It doesn't stop you from doing that. So if you have forgotten to add a column family, so address is a column, right? So we do not define column upfront anyway. We only define column families. If address is a column family, then you have to create a new table, and then so if you want to add it to all employees, yes, you have to call put on each row. It doesn't provide you a very great insert queries. All right. So now further to Ravi's question. All right. This is the answer is yes. And let me put it together. All right. There's another question from Randhir. What if, for example, oh, I'm adding it somewhere else. Okay. So what if, for example, we want to add address under so if you are adding a column in a column family, that's not adding a new column family, right? That's completely acceptable. Yeah, but if you are changing the table definition, meaning you are adding want to add one more column family, create a fresh new column family, then there's a problem. Then you have to create another table, copy the data from old table to new table, and then move. All right, Ravi. Now, Randy's question is, can we join two tables after adding new column family? You cannot do normal joins. Okay, joins are not part of HBase. Okay, you can do joins using table MR. The table MR which we just talked about here, we could define a source table combining multiple tables. I think you can define multiple tables. Okay, I need to check that. All right. I'm not sure actually. So joins are something which are very difficult in HBase. For that matter, every NoSQL will have big problems with joins. That's why you generally try to keep the whole data which need to be churned together in a single table. All right. So So Ganpati's point is right. So we are generally joining using HBase and NoSQL to avoid joins because if you try to keep lot of joins, then the churning of data becomes really tough. Therefore, these architectures are designed in this manner. All right. So we are almost through the Bloom filter. All right. So we'll see you next weekend, and we will go ahead with Hive and other aspects, Zookeeper and other important concept. All right. See you next week. Bye bye. Have a good day. So Randhir, you just once this session finishes, it will ask you for converting. I'm talking to Randhir because Randhir is also recording today's video. And once you're done with it, I will let you know You can just send me the link to the video after uploading somewhere, maybe on YouTube, and then we will download it and put it on our YouTube channel. All right. Let it convert. Let it convert, and after converting, you upload it somewhere. Maybe put it in Dropbox. Okay, and then we'll delete it from Dropbox. All right. Thank you very much. Have a good day. Bye bye.